Hey, this is Mr. 8, and this is Pre-Calculus Honors. This is section 2.3, Real Zeros of Polynomial Functions. We are going to be taking a look at these polynomial functions that we've been looking at, and we're going to find out some different ways to find out real zeros of that function. When does that graph cross that x-axis? What is the real zeros of my function? So let's consider this graph right here. We have the graph of the function of x is equal to 6x cubed minus 19x squared plus 16x minus 4. I graphed it using GeoGebra, and take a look right here. We know we have a real zero right here at x is equal to 2, okay? And so we also have a real zero right here at 0.5. We have another real zero right here at some fractional value, okay? And so I know some of my real zeros of this function. I have 3 possible real zeros, and I have 3 real zeros when it crosses this x-axis. And so we're going to be using what's called long division. Yes, long division. From a long time ago, we know that one of my factors was x is equal to -2, which means x minus 2 is a factor of this. And so we're going to use long division. We're going to take x minus 2, and we're going to do a long division into 6x cubed minus 19x squared plus 16x minus 4. Okay, and so we're going to use the same thing that you did in elementary school of long division. So I take a look at this first number, x. How many times does x go into 6x cubed? It goes 6x squared. And so I'm going to take this 6x squared, I'm going to multiply by everything in here. I'm going to kind of like distribute. So 6x squared times x is 6x cubed. 6x squared times -2 is equal to -12x squared. And just like you did in a long time ago in elementary school, you are going to subtract this, which means all your signs change. That cancels him out, of course. That's what we're trying to do. And we're left with -7x squared. We're going to bring this guy down, plus 16x. Yes, this is just like elementary school, except you're using factors and polynomials. So how many times does x go into -7x squared? Is -7x. So we're going to multiply again. -7x times x is -7x squared. -7x times 2 is positive 14x. And I'm going to subtract everything here. And so when I subtract everything, it changes all my signs. This becomes 0. This becomes 2x minus 4. And then we go back. We brought that -4 down. How many times does x go into 2x? It goes 2 times, which means now I distribute. 2 times x is 2x minus 4. Everything goes the other signs. Everything cancels out, which means this was one of my factors. So what am I left with is I have 6x squared minus 7x plus 2. Okay. Now, you can kind of ask yourself, are you able to factor this guy completely? Yeah, you are able to factor this one into a 2x, and we have a 3x, and our factors of 2 is -1, -2. So this factored out. We still have, remember, don't forget, we had this factor right here, this x minus 2 factor as well. And so you can see, what are my real zeros? My real zeros are x is equal to 2. We figured that out. This one, x is equal to, I always cover up this 2 to figure it out. X minus 1 is 1. Then whatever is in front, I divide. That's at 1/2. This one right here, x is equal to what cancels out this -1 is 1. This 3 goes on the denominator, 1/3. And that was my factors. We had x is equal to 2. X is equal to 0.5, and x is equal to, this is a 2 right here. This is a 2 right here. Sorry, I factored that wrong, which means we have a 2 right there, 2/3, and that matches my graph right here of 2/3, or 0.66666666666. And sorry about that little mistake there. That is your long division. And you might say, I hate long division. Amen, brother and sister. So let's take a look at this long division. We have x plus 1. We're going to divide into x squared plus 3x plus 5. And so x goes into x squared, x number of times. I multiply, x times x is x squared, x times 1 is 1x. What do? We change all the signs. That makes him 0. That makes him 2x. We bring this 5 down, plus 5. How many times does x go into 2? We have 2. So we have 2x plus 2. We change the signs. That becomes 0. That becomes 3, which means I have a remainder of 3. Remember that from elementary school when you might have a remainder. And so you can see, what are my factors? My factors are, and I can write this in this case, is my factors are x plus 1 times x plus 2 plus a remainder of 3. X plus 1, and that is what f of x is equal to, is x plus 1, x plus 2, plus 3. If you take a look at your zeros, you have a 0 at x is equal to negative 1. You have a 0 at x is equal to negative 2. And you have a remainder of 3 here. It did not go in perfectly. Again, it did not go in perfectly. You could also say this, if I had the question divide this function by x plus 1, the answer is x plus 2 plus a remainder of 3 over, what do we always put our remainder over? Whatever our divisor was, x plus 1. And so that would be the answer, x plus 2 plus the remainder of 3 over x plus 1. Okay. Now, again, long division bites the big one. It just stinks. So guess what? We have an easier way of doing things in pre-calculus. Amen, brother and sister. And so let's go back to this original function. Okay, this original function right here. Now, we did all of this work to find out this. There's an easier way to do it, and it's called synthetic division. Okay, so you take a look at your factor, x minus 2. So that means x is equal to 2 is a 0, which means we're going to put a 2 right here. Okay, and we're going to do what's called synthetic division, which means we're just going to take the coefficients here. We're going to take this 6 because he was the x cubed, negative 19 because he was the x squared, 16 because he was the x, and minus 4. Now remember, if we didn't have this x squared, we would have to put a 0 here. Okay, so just keep that in mind. We'll see that in the next example. I think the next example. And so this is how you do synthetic division. You're going to bring this number down, 6. Okay, 6 times 2, we're going to multiply. 6 times 2 is 12. Then we're going to add these two numbers, and we get negative 7. Negative 7 times 2 is negative 14. We're going to add these numbers. We get positive 2. 2 times 2 is 4. This becomes 0, which means because I had a remainder of 0, that means that this bad boy was a factor. X is equal to 2 was the solution for the factor of x minus 2. And my remainder is going to be 6x squared. Now, why would it be x squared? It's because I'm dividing x to the first power into this. And so the powers go down 1. So we have 6x squared minus 7x, remember the powers go down, plus 2. That's the remaining factor. We had x minus 2 was a factor, and we had this 6x squared minus 7x plus 2, which means guess what we can do? We can factor this last guy completely out to what I factored him out to be before, which was 2x minus 1 and 3x minus 2. And there was all of my factors of my function of f of x. And that's called synthetic division. Okay, let me give you another example. We're going to perform synthetic division on this function right here, which means we're going to divide. We don't have to do long division. Okay, stop doing long division. It's not quick and easy. So here, look at my answer. My answer is going to be x is equal to negative 3. That's what my solution is. So negative 3 is what I'm going to do synthetic division on. So what's my coefficient on x to the 4th is 1. What's my coefficient on x to the 3rd? There's nothing on x to the 3rd. Do you guys see that? There was 1 on x to the 4th. There was 0 on x to the 3rd. There's negative 10 on x squared. There's negative 2 on x to the first power. There's 4 on x to the 0 power. Okay. So now we're going to do synthetic division. We're going to bring this guy down. That's going to be 1. 1 times negative 3 is negative 3. We add this, negative 3. Negative 3 times negative 3 is 9. We add this, we get negative 1. Negative 1 times negative 3 is positive 3. We add this, we get 1. 1 times negative 3 is negative 3, which means my remainder is 1. I have a remainder of 1. So this guy, you can say, when we divided this function into this, we end up getting, remember, we were dividing x to the first power, so we get 1x to the third power, because our power goes down, minus 3x squared, minus 1x, plus 1, with a remainder of 1 over what we were dividing by, x plus 3. And so that is my dividing by synthetic division. Now, if you have a remainder of 0, it's a perfect factor of your polynomial function. Okay, and then we have the remainder theorem. It's really easy. The remainder theorem found by using synthetic division at a value is the same as the evaluation of a polynomial at that same value. And you're like, say what? What does that mean? Well, it means something really cool. It means you could take negative 2 and plug him in. 3 times negative 2, when we do f of negative 2, we're going to plug negative 2 in for x. 3 negative 2 to the third power, plus 8 times negative 2 squared, plus 5 times negative 2 minus 7. And so negative 2 to the third power is negative 8. Negative 8 times 3 is negative 24. We have negative 2 squared, that's 4. 4 times 8 is 32. Negative 5 times 2 is negative 10. We have negative 7. Let's add all of that up. So negative 24 and 32, that gives us 8. That 8 minus 7 is 1. I'm doing this all in my mind. So we get an answer of negative 9. So f of negative 2 equals negative 9. Okay. Let me show you a different way to do this. We want to evaluate this value, which means I can do synthetic division really quickly. We have 3, that's the x cubed. 8 is the x squared. 5 is the x, negative 7. So we bring down 3 times negative 2 is negative 6. We add this. 2 times negative 2 is negative 4. We get 1. 1 times negative 2 is negative 2. That gives us negative 9. Negative 9 is the remainder. That is the evaluation of your function. And so you can plug a number in and do an evaluation, or you can do synthetic division and find out the remainder, which means if the remainder is 0, that means that this is going to be a solution to your polynomial. This will give you one of your real zeros. But if you have a remainder, it's just like you're evaluating it. And you might say, Mr. Reed, it wasn't hard to plug negative 2 in there. Well, it is when you have x to the fourth power, x to the fifth power, and it takes a long time. Okay, as opposed to synthetic division is really quick and simple. So let me show you something like this, where we want to know if both of these, x minus 2 and x plus 3, are factors, which means x equals 2 and x is equal to negative 3. We're trying to see if these are both factors. So we're going to do synthetic division because it's way, way, way easier than doing long division. We have 2x to the fourth, we have 7x to the third, negative 4x squared, negative 27x, negative 18. So we're going to bring this down. 2 times 2 is 4. We get 11. 11 times 2 is 22. 22 minus 4 is 18. 18 times 2 is 36. We're getting much harder here. We get 9. 9 times 2 is 18. Guess what? I got a remainder of 0. Ding, 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 ding. Which means if we just divided x minus 2 into this, we would end up getting 2x to the third power plus 11x squared plus 18x plus 18x plus 9. That would be the leftover function, okay, when I did x minus 2. And so we knew this was a factor because it gave us a remainder of 0. Now, we can continue on. We don't have to take negative 3 and put it into this original function. We can continue negative 3 into the leftover function, okay, which means we can do repeated divisions. And because if it's a 0, it's going to be 0 at the beginning or in the middle. It's always going to be a 0. So we get 2. 2 times negative 3 is negative 6. We add that up. We get 5. 5 times negative 3 is negative 15. We end up getting 3. 3 times negative 3 is 9. Negative 9 and 9 is 0, which means ding, 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 ding. This is a 0. Which means what are we left with? We had the factor of x minus 2. We have this factor of x plus 3. And what are we left with? We're left with 2x squared plus 5x plus 3. And that's what we have left. Now you can ask yourself, we knew we had x minus 2, that was this one up here. We have x plus 3, that's this one in orange. And then can we factor this last guy? Once we get down to an x squared, we can just do normal factoring, which is awesome. We end up getting 2x. We end up getting x because 2x times x is 2x squared. What's the factors of 3? Is 3 times 1, which add up to, we can see the 3x and the 2x ends up becoming 5x, doesn't it? Which is awesome. And so we have that happening. We have, that doesn't work, does it? I'm sorry. We're going to have to flip this guy because that would be too much. 3 and 1. There we go. We have 2x times 1. It's 2x. 3x right here. That adds up to 5x. So there we go. There are my factors. And take a look. Here are my zeros. X is equal to 2 is a 0. X is equal to negative 3 is a 0. This one, x is equal to, what cancels out with this? Positive 3 is negative 3. What do we do with the 2? We put them on the denominator, negative 3 halves. And x is equal to negative 1 on this guy. Those are all my zeros. Okay? And that's where we can use repeated division. We also have this thing called the rational zero test. The rational zero test basically gives us, we have Descartes' rule of signs, which I think is kind of stupid. I know I'm the only math teacher that thinks Descartes' rule of signs is stupid. The rational zero test also says if you look at the front number, the front coefficient, and the back coefficient, you can know theoretically what possible rational zeros are going to be. Okay, and so this p factor is this factor right here, and this q factor is this factor right here. And if you put p over q, and you find out all the possible combinations of this guy, you can figure out what the rational zeros are. So if I take a look at this, if I take a look at this guy right here, we have 1. If I take a look at this guy right here, we have 1. Okay, which means all the factors of plus or minus 1 could be rational zeros, which means you could have 0, x equals plus 1, you could have x is equal to negative 1, and it gives you kind of a starting point to take a look at what your zeros are. It's just something that helps you to kind of guess what you want to start with synthetic division. Okay, so take a look right here. We're always going to look at the back number, this 3, okay? And we take a look, what are the possible real zeros of this 3? Okay, we're going to have the factors of 3 and 1. You could have positive 3, you can have negative 3, you can have positive 1, you can have negative 1. Okay, now we take a look at this guy right here. What are the factors of 2? We could have 2, we could have 2, we could have 2, we could have 2, we could have 1. So positive 3 over 1, negative 3 over 1. Positive 1 over 1, negative 1 over 1. Okay, so what it does is the beginning and the end numbers, if you put them over each other, all those factors are possible values. They're possible. Doesn't say they are, but they're possible values. What it does is it really helps you to try to figure out what your rational zeros are. Okay, so if you can see, and really, I kind of start with this number first. What are the factors of this number right here? Is plus or minus 3, plus or minus 1. So let's start with those. We're going to see if they cancel each other out. So let me just start with 1. I'm just going to guess. Okay. Remember, synthetic division is so quick that if you mess up or if it doesn't give you a remainder of 0, you can try the other guy. Okay, so we start out with 2. 2 times 1 is 2. We get 5. 5 times 1 is 5. We get negative 3. Negative 3 times 1 equals negative 3. Guess what? I fished my wish on the first try. I know that x is equal to 1 is a 0. Ding, ding, dong. We got it. Okay, which means what am I left with? I'm left with the function 2x squared plus 5x minus 3. And let me see if that guy factors. What are the factors of 2x squared, or 2x times x? What are the factors of negative 3? Is you have negative 1 plus 3. Let's see if that works. So we have Negative 3 times 1 is negative 3. Let's look at the middle number. 2x times 3, that's 6x. Negative 1x, that gives me 5x, which means I know my other zeros. My other zeros are x is equal to 1 divided by 2, and x is equal to negative 3. So guess what? I know all my zeros. X is equal to 1. Don't forget the 1 at the start. X is equal to 1/2. X is equal to negative 3. That's what you would see on your graph. And if you wanted to kind of graph that out, you would know. You would say, all right, I have 1, 2, 3. We have a 0 right here. We have a 0 at 1. We have a 0 at 1/2 right here. Okay. It's an x cubed graph, so remember what we did before. This graph is going to go up and down and then up, and that's what my graph is going to look like. Okay. Now remember, since synthetic division is so quick, let's say I started with negative 1. Okay, negative 1, and I went 2, 3, negative 8, and 3, and I have 2, negative 2, that's 1, that's negative 1, that's negative 9. Oh, that's not going to give me a remainder of 0. That's wrong. Let me go to positive 1. Okay, you can do it so quickly with synthetic division. It really, really helps out. Now I know, guys, that was a long video. That was a lot of stuff. We're trying to find real zeros of polynomial functions. Long division or synthetic division? I say use synthetic. Have a good day, guys. Catch you on the flip side.